Hey, how you doing? It's Clint Mason with Guys and Well Solutions. I'm going to just talk a little bit about plunger types, seals, and how plunger actually creates a seal, and talk about some of their applications where you might use the type of seals. So, how does a plunger work? Well, there's a lot of misinformation about plungers. We'll try to dispel some of that and also help you understand how to pick the proper plunger seal type, when you should be adjusting or replacing, and yeah, just general applications. So it's a seal. The plunger creates a seal by creating basically um, a restriction in the tubing. So there's gas from the bottom, high pressure gas. It flows across the surface of the plunger and then moves to a low pressure side. Now, the pressure across that plunger is typically going to be what is required to make that plunger move. So if it's 3 psi, 3 pounds per square inch, pushing on the bottom of that plunger differential, and that plunger will lift or move at that, that's basically what the differential or the weight of that plunger is to move it. That's the forces it'll take. Now, people think that, well, if I have a barrel of fluid on top of it, and for example, a 2 3/8, a barrel of water weighs probably about 170 pounds per square inch. So for every square inch, you've got 170 pounds pushing on top of this plunger. And then we'd have about 3 psi in this type of a plunger of weight, pounds per square inch. So we need 173 pounds of differential to probably, well, basically equalize that weight. And then of course you've got to get it moving. So you might require, closer to a 300 psi differential in the well casing to tubing in order to lift that fluid. Now, we don't get too much into that, but it's important to know that the seal is not really a seal. All we're doing is creating restriction and turbulence and slowing that gas that wants to flow past that plunger in order to create this differential that allows that plunger to move up underneath the fluid. Okay. So if you don't have enough flow across that plunger, first of all, the plunger won't move very effectively. Secondly, liquid will start to fall back down around the outside. So you got to have enough gas going by this plunger to support the liquid that's above it. So, so here's, you've got gas breaking around the outside. And as that gas is coming around the outside, in this case, it's an example of a ring or a rib type plunger. Gas goes across these ribs, creates eddies and turbulence and stuff like that. That turbulence also helps increase the lift. Also, every one of these surface areas that there's a differential across increases that ability. But if you didn't have these ribs or these different surfaces, what would happen is you would get what's called channeling. So if this was just a one solid piece of metal without any kind of profile on it, you'd probably have gas channel and break up one side and liquid just fall down the other. And so it's important to have these type of surfaces in a ring type plunger, for example, to minimize the chance of that happening. So it does increase the efficiency. So there's just an example. The plungers are going by, little animation. But as that turbulence is moving, it's definitely helping create an increased seal. Now, one of the things that's really important to know is that a solid plunger, a ring type plunger, can never be greater than tubing drift. If it's bigger than tubing drift, there's a good chance that it could get stuck. Now, typically your drift area, when you talk about tubing drift is the smallest area that should be in that tubing. So, for example, standard 2 3/8 tubing would have a drift of about 1.901 inches, and that's typically going to be in the collar area here. So, when the plunger tries to go between the two joints where the collar is, that's going to be probably around 1.901 minimum. So that's the size. Now, what's interesting and people don't realize is it's a very small piece of the tubing. When you get up to the middle of the tubing, most of that tubing is probably 195, 196, 197. So there ends up being quite a bit of area flow around a plunger. So right away, that large area is one of the reasons why solid plungers are typically not as efficient as a pad type plunger or some of the other style of plungers like a brush or whatever. Now, here's an example of a pad. Now, why is a pad plunger more efficient? Is basically these spring-loaded pads are able to push towards the tubing wall, and when they come to a tight spot, they can collapse and then they can expand into these larger areas. So it's keeping that area between the plunger and the tubing very, very tight. What's kind of interesting also is that when the plunger is traveling up and there's gas pushing underneath, that gas force is actually pushing these pads in, and they're not typically pushed right out to the wall. The gas is actually still running by them. They're not creating a metal on metal seal. Now there might be a little bit of wear. You'll typically see these pads will wear more on the tops if they're like a dual spring type pad because there's actually more pressure pushing the pad back in than at the top. So they run up the well at kind of an angle, so they'll wear more on one side than on the other. The other thing that's kind of interesting is, and we'll talk more about why you shouldn't use these in a wax or a paraffin application, is that because the pads are collapsible, when you're bringing them up, they actually squeeze in just a little bit. That gas going by them pushes them in. And if you're leaving even a very small microfilm of paraffin on the tubing wall, when that plunger goes up, okay, it's squeezed in. And then when you, of course, stop flowing the well, those pads, the springs are able to push back out. And when it tries to drop, it is rubbing down the tubing wall. So even if you left a very, very thin layer of paraffin, that paraffin will start to build up underneath the pad and it can hang up the plunger. So that's one of the reasons why you wouldn't use a pad in a paraffin application is just by that action, because it compresses and then it expands fully on the way down. So there's that's definitely one of the things you have to watch for. Asked all the time, when do we replace the plunger? Um, and everybody wants to know what is the wear? Do we replace it at 20 thou? Do we replace it at 30 thou? Or what? Well, the simple answer is that a plunger should be replaced when it impacts your production. And anybody that tells you you should do it at 20 thou, it's not being honest. You should replace the plunger when it impacts production. Some wells that can be 5,000, 10,000, 15,000, 20,000. I've seen plungers run on wells that are wore out to where there's almost no ribs, and the wells are doing fine. It's just that strong of well. But one of the easiest ways to um, decide or figure out how, when you should replace that plunger is your operator should be carrying some plungers in their trucks. And every month or so, they should go out there and, look at a couple of wells and drop a plunger in and look at the production that, yesterday and put the plunger in and look at the production tomorrow. And did we see an increase? Did we see an improvement? And if you see an improvement, then that plunger that you took out is worn too much. You let it run too long, and that could be 1 month, 2 months, 3 months, 6 months, a year. It doesn't really matter. But once you've identified when it makes that uptick again back in that well, that's a good information to have, because if I was let's say it was 3 months between the new plunger and when I put in the next plunger, what that tells me is that 3 months from now that I put the new plunger in, I'm probably going to need another plunger replacement. And what's interesting, other than maybe the first or second plunger install or that you replace, you'll start seeing that those plungers wear at a very consistent rate typically. So if it wore out in 3 months in this well before, it's going to wear out in 3 months the next time. And they pretty well stay like that. I mean, over many, many years, you might start to see extended because it's going to just rub all the little rough edges off the tubing. But generally, you can take it to the bank. If I replaced it in 3 months and I made an improvement, if I replace it again in 3 months, it's going to make an improvement, or 6 months, or whatever that is. So don't be don't be concerned about the OD. Be more concerned on what production impact it has on your wells. And so that's the first thing to talk about. The larger gap between the tubing wall and the plunger, and the more, as as these plungers wear, and what's really happening is, think of it almost like an orifice plate, right? We've got if you got a tiny little hole and you're trying to push gas through that, you get a great big huge differential across that orifice plate, even at a very slow rate. The bigger that hole is in that orifice plate, the more gas you can flow through with no differential. Well, this wear, it works the same way. As the plunger wears, that hole just keeps getting bigger and bigger and bigger, and we're going to form less and lower, or it's going to take more gas going through that hole to create the same differential. So when we're talking about how a plunger gets, the differential across it to move, if I need to create 3 psi to make that plunger move in the column, uh, a brand new plunger, it might only take a very small amount of gas, 30 or 40 MCF from bottom. And if I wear that plunger out even just a little bit, that could significantly increase. Like I say, with a 20 thou wear, you can increase the bypass or flow area, this area between the plunger and the tubing, by close to 50%. Important uh, point, especially about, well, mostly about a rib or a solid seal plunger, is efficiency is not just the OD of the plunger. What even has a bigger impact than the OD is the overall length of the seal surface. So from the point here to this point here, the longer that area is, the more efficient the plunger will be. Now, don't these when I call them plunger efficiency averages, it's probably kind of a misleading. What this was is we took some, how much gas flow did we need? What kind of pressure differential we get across a plunger? There are several factors that we put into a bit of an equation that created this percentage efficiency. Now, it doesn't really mean that 10-inch plunger is only going to lift 42% of the fluid from the bottom. If you start off with a barrel, you're only going to get 42% there. That's really more an efficiency on the energy that it's using, how much gas it has to flow by, how efficient is the seal, and all that stuff. But really what was quite interesting is when we got up to here with a 24-inch plunger, where we had a seal that was close to 24 inches long, we were almost as efficient as an average dual pad plunger. Um, there was a time that we built some 90-inch long plungers that were designed to span side pocket mandrels. And we used basically two 24-inch plungers on either side of a big long spacer bar. And those plungers were so efficient with those two 24-inch seals that when we tried to drop them, you actually couldn't get those plungers to fall. You couldn't get, it would get into the tubing, and they just wouldn't fall. It barely moved going down. And well, was it wax? Was it this? Was it that? No, it was just strictly, there was so much seal area that plunger would not fall. So what we ended up doing was we significantly reduced the OD of those plungers, and we went from a 190 full drift plunger, all sorts of sealing efficiency, down to a 186 with two 24-inch plungers to actually get that plunger to fall around 50 meters per minute, or 150 feet per minute, which was surprising to us how much that impacted those wells, the lengths of those plungers. Because these are, a 90-inch plunger is quite heavy, two 24-inch. You'd think that thing would fall like crazy, but it just wouldn't. So it's really has a big impact. So for you that are working out there, you have plungers or wells where you've got paraffins and the wells are getting weaker. Don't fall for the cheap little 10-inch plunger because it's cheap and you can get that for nothing. You may find that if you're having trouble getting that plunger into the wellhead, or cycling, or you know running properly, you want to start extending the length of that plunger. Now, like I showed here, a 24-inch plunger is significantly more efficient than a 10 or a 12-inch seal blank plunger. So the average is somewhere around here, 12 to 15 inches. That's a pretty average, I would say, the workhorse of most of the plungers that most companies have. But anyway, just thought that was pretty interesting. Plunger efficiency. So A plunger that's worn from 190 to 188 can actually, and as it says, lose over 50% of its seal efficiency. Really, what it means is it increases the bypass area between the tubing and the plunger by probably 50%, roughly. So there's a lot bigger area that it can flow by, and that we've seen that when we track plungers using echometer and different uh, methods, uh, trying different plunger ODs and how that reacts in a well. Uh, when a plunger is in a deviated section of the tubing, it also loses some of its efficiency. It's interesting when we're following plungers that might be dropping and then they get to just a dog leg in the well and it kind of kicks over and it goes straight again. We'll actually see the plunger speed up going through that dog leg, even though you think they'd slow down because they're laying against the tubing wall. But really what's happened is they just fall against that tubing and there's so much bypass area created over the top, or there's less restriction because of the plunger when it's falling in a nice vertical, it's shaking them. You can hear them like they're rattling down and it's bouncing and it's really creating all sorts of extra turbulence and restriction as it's falling down the well. When it gets on its side, it lays flat on that dog leg and it just has a large bypass area on the top and that plunger will actually speed up and we see that all the time. So it'll have the same effect coming up. If you've got a well that has a large dog leg in the middle of a vertical well, you may be having a lot of trouble getting through that section and can really impact the way those wells cycle. So that's something to be aware of if you're looking at your completions. This also is a potential fluid hang-up area. Uh, there's a whole other subject I have when I've got about liquid loading in a horizontal. We know that if you get a fairly significant dog leg, the same things that are happening in a horizontal well as it goes through the transitional are actually happening in those dog legs. So you've got liquid falling down there, even though the well you think it's above critical rate, it's really a liquid hang up area. So something to look at. You want to pick the right plunger to work with the build-up speed. Now we haven't talked too much. We've been talking about seal types, not plunger types. So you typically have a ball and sleeve, two-piece pacemaker, free cycle, rapid cycle, quick trip. There's all sorts of different names for it. Then you'll have like the Venturi, Ventromax, Rattler is another one. We've got the ProFlight plunger that we use, so that which has a little bypass port in it that increases that flow area. Um, and then you'll have your conventional plunger. So if you have a well that builds up, if you've got a well that if you're going to drop a conventional, it takes 15 minutes for that plunger to fall from surface to bottom to where your bottom hole spring is. But if your well is building up fast enough and almost becoming stable, let's say in about 20 minutes of flow time, so it snaps up and builds and kind of levels up if you're at the top if you're watching your build up if it levels off. So but you're going to leave the well shut in for an extra 30 minutes, even though you're not building up pressure anymore. It's probably the wrong application to use a conventional. That time you might be looking at maybe the Ventral Max Rattler or whatever, where it can actually fall a little quicker. They also can impact your efficiency a little bit. Or maybe it's a free cycle plunger that opens a valve and lets it zip down there quickly so you can bring it back on as soon as you're ready. So the right plunger makes a big difference on the overall production of the well. But we'll talk more about choosing the right plunger style in another video. So anyway, this next section, we're just going to talk about seal types and kind of their applications, just where I would suggest to use a seal type and what application. It's not not the plunger type, it's the seal type. So we're talking solid, ring type, brush, pad. Those are kind of the three main ones we would use. So we're going to talk about in this next section. So you've got a solid plunger. Here's an example of a solid plunger. It has a solid seal face, can't be collapsed, so it's not going to do well. And if you have tight spots or problems in the tubing, the pro is they're typically low cost. Some of the cons are they can be inefficient, but as we talked about, properly designed solid plunger and the length of that plunger can really swing that plunger from an inefficient plunger to quite an efficient plunger. Mostly used when we have wax or solids and kind of a general use, the general workhorse of most plunger lift applications. There's another example where we have the ribs in it that are cut into it that'll make that plunger spin a bit when it's falling or in a gas stream. Then we have a brush. Now the brush is flexible surface. They're typically made of nylon. Sometimes they're like a coil that's slid onto a mandrel. Sometimes they're actually wrapped and wired right to the plunger body. Um, they have an incredible seal. In fact, some of the best seal you can get. But unfortunately, that seal lasts a very, very short time. Typically, this soft face wears very quickly. It can be affected by heat. So if you're putting it into a fairly deep well with a lot of high bottom hole temperature, it'll actually shrink that material very quickly. And once you've wore the fibers down to typically the plunger bodies here on the end will be like 186 or something like that. So it'll typically wear these fibers down very quickly, and then you've just got a 186 OD type plunger in a 22312, and you do lose a lot of efficiency. Where I do like to use them is where you have some restricted tubing, where you might not be able to use a solid, and you have solids. If I had restricted tubing and I didn't have solids, then I would probably run a pad plunger. If I just have sand, I would typically try to run it with a solid or a ring type seal first. I just find they work as good, if not better, than brushes. Lots of times you'll find the brush, depending on the sand type, it'll actually pack into the brush, come up, and it'll actually stick in the lubricators where we can get solids to clean. They'll kind of clean when they come into the lubricator a little bit better. So a pad plunger has pad seal like pads that are spring loaded, and they're multiple pads all the way around the plunger. They have an excellent seal, and the other nice thing is as they wear, they kind of keep pushing out so they can maintain that seal, high quality, efficient seal over a long period of time. Like on like a solid plunger, like even if you run a long plunger, the second you put that plunger in, it starts to wear. Well, the efficiency starts to uh, get less, as the plunger wears. But the pad will kind of wear into the tubing, and even some pads actually become a little more efficient over time. A new plunger won't be as efficient as one that's a month old because of the way that it can wear into the tubing, and the face of the pads kind of start to mate up better with the tubing itself. So they do have a great application, but I typically look to use them in lower rate wells, lower GLR wells. They have to be clean, and you never would use them with wax or solids. If you got a nice clean well that's making a nice clean oil or a nice clean water, great solution. If you have a really strong well, though, there's probably not a lot of advantages putting these more expensive plungers into the well like that. So there's some examples of different bar stock or solid type plungers. Most of them work pretty good. I mean, again, I think a longer plunger is much more efficient than a short little stubby plunger. Some have thicker ribs, some have thinner ribs. I mean, there's all sorts of different designs and seals and reasons for doing that. The part that's interesting is these little ribs or veins or whatever. Anybody who's run a plunger with those type of vanes, you'll know when that plunger's sitting in the lubricator, lots of times you can hear them spin and carry on. And what they're really useful for is if you've got a well with a bit of a deviation, you'll find that a lot of times a nice straight plunger like this actually starts to wear on one side. So how that happens is these plungers are not balanced or anything, right? So you'll always have one side of the plunger that's a little heavier than the other. So as the plunger's falling, and as it starts to fall and turn into on lay on its side, the heaviest side of the plunger rolls over and starts to wear, and it starts to create a wear face on that downward side. Now you would think, okay, well, where's some material off? It should get lighter, and it should roll over. But that's not what happens. What happens is it flops around and rolls and gets into that saddle, and once it's in that saddle, it just keeps wearing. It gets worse and worse and worse. So if you're seeing plungers that are wearing on one side, that's really what's happened. Is it started to create that saddle, and then it's just falling in that saddle every time it gets into a dog leg or deviation or whatever. these ribs or these vents or whatever you want to call them, the the veins do spin that plunger, and as that plunger is falling, it'll typically stop it from landing always on that one side, or even if it's falling, it'll spin enough that it doesn't create that saddle. I would call it saddle. I don't know if that's the right word, but and then you're able to wear those plungers more efficiently. Now, I've had a lot of people ask me, sort of comment that it does better in wax, do better coming through wellheads and things like that. I do know from testing that when we put a plunger like this here in a test apparatus and we just hang it in gas blowing by it and we keep it suspended there, those things will spin like crazy. The second we even add 1 cup of water that gets around that plunger stops spinning. And because there's enough resistance from the liquids between the plunger, the liquid, and the tubing that it just doesn't really let it move anymore. So they're probably not spinning on the way up under a bunch of fluid or as they're lifting fluid, but I think they're definitely spinning on the way down. Now, it doesn't mean that, I've had people say it works better on wax and I can't say it does or it doesn't. I've seen both different types work better. I've seen this type work better in one well and this type work better in a different well with similar problems. So I don't know what other advantages it has beyond that, but the simple fact is if it works for you, use the one that you prefer. If it makes you happy, honestly, it's going to work. It's going to perform better. Here's our brush plunger. Again, to recap, extremely efficient seal when they're brand new, typically, but that seal quickly disappears as it wears out and you lose it. Um, I would never use those plungers in paraffin or asphaltene. Again, these things will just bung up with a bunch of paraffin, come up to the lubricator and blunk, stick in the lubricator, or only go part way down, and then you get some fast plunger arrival. So paraffin and brush plungers are a definite poor mix, and they typically don't maintain that seal for a long time. So it's kind of a recap on that. Typically, you'll find that these steel areas above the pads are undersized. Like I was mentioning, they should be like probably in a 2 3/8, 1/8/6, and that wears this brush pretty quickly within a month or so, or even last sometimes weeks or days. This seal can be wore down quite small, and then you start losing a lot of that efficiency that you were getting when you first put them in. Pad, blade, plungers. Here's an example of a single pad, dual pad. I've seen triple pads, things like that. You know, they are a great plunger. In when we were doing mostly vertical, stripper gas wells with a little bit of water and stuff, these were the #1 plunger. They always worked the best. They had the best seal. This type of plunger was the real go-to plunger. Today, the majority of our work is in shales and things, and we're getting a lot more paraffins and sands and other issues, which pad plungers are not great in. You definitely don't want to run a pad again if you get any kind of sand. It can pack in behind these pads, lock them out. You can get the plunger stuck. I explained before how paraffin can be left behind because of the way the pads get compressed, and then they can expand on the way down, allows the plunger to hang up. Then you get some fast runs and smash stuff up. So the only time I would recommend that you're looking at these plungers again, nice clean well, can be nice clean oil, can be nice clean water, no sand, very, very tiny, if any paraffin at all. And if you've got a weak well where you need that really high efficiency. If you don't, look at a solid plunger, run a little longer plunger, whatever, and it'll last a long time, or it'll last very well. You have fewer moving parts, and typically your cost of operations is going to be a little bit better than running a pad in a higher rate well because you're not going to be pounding on them so hard. In a low rate well, 100%. great application. So that's my discussion about plunger seals and sort of their application. I'll have another short presentation. I guess it's not that short. It's almost 30 minutes long now. So I was hoping to keep that around 15, but talk too much. But anyways, hope you got something out of it and some information on how pads work and their application. If you have any questions, reach out to us at info@kaizenws.com. That's KAIZENWS.com. Or you can check us out on our website. Here it is. Anyways, have a great day. Be safe.